Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic or on premise, and, when we can be there, on location on premises. Each time we meet, we bring together a group of IT luminaries to discuss a single concept. In this episode, which is related to our AI Field Day event, the question revolves around storage and AI. Specifically, do you need high-performance specialized storage systems to support AI solutions? I'm going to say yes, you do, but we'll see what the panel thinks. So before we begin, let's meet our guests. Karen?
Hi, I'm Karen Lopez. I'm based in Toronto in the Great White North, and I'm Data Chick on Twitter. And you can see I'm a data person.
I'm Andy Banta. I am at Andy Banta on Twitter. I am the world-famous storage janitor, and I am based right here.
But sometimes you're on premises, right? I mean, we'll get there.
Sometimes I am on premises.
So here's the thing. So you've got basically the data check and the storage dude here, storage janitor here. What's the question here? The question is, you look at AI Field Day, you look at the types of components that are being built into the AI stack, and storage is emerging as basically a must-have. In fact, I would go so far as to say that from the outside looking in, it appears that all the purveyors of big AI training systems are partnering, desperately scrambling to partner with high-performance distributed storage solutions. And the only reason I can think of that is because that must be a requirement. That must be something they need. Karen, I'm going to start with you. Do you think that AI systems need storage in order to function?
Well, of course they need storage, but specialized storage, I say, why not? I mean, we know that databases need specialized storage. We know that streaming and edge things need specialized storage. I think I might have answered this question differently, say 15 years ago. But now that we have like the ultimate agile storage of software defined storage, software optimized storage, storage that can be agile, that can scale up and scale out almost instantly. Like, why not? Of course, why wouldn't we optimize storage for AI and ML workloads?
I think there's an awful lot of AI solutions out there that attempt to come up with specialized solutions on how to connect the storage, but I don't necessarily think that the storage itself has to be anything special. I mean, NVIDIA has come out recently with the DMA access directly into GPU engines. There's all sorts of new NVMe interconnects. There's all sorts of no buffer write type solutions that are out there, and these are all sorts of technologies that are available that AI can, of course, take advantage of. But it's not like these are things that were specifically designed for AI. It's not things that AI specifically says, "Oh yeah, I need this." These are storage technologies that are working in harmony with AI, but it's not like there's actually any need to do a specialized storage system for AI. AI would use whatever storage was available to it, and these new technologies came along and they work well with AI, but they aren't necessarily specifically designed for AI.
Well, that's certainly true. I mean, you look at the solutions that we're talking about here, companies like, DDN, WEKA, NetApp, we're going to be seeing those at AI Field Day this week. And you look at those products and fundamentally, I mean, certainly they've done a lot of work on those systems, but fundamentally those systems are the way they are because of the needs of enterprise tech generally, not specifically because AI needs it. In fact, I think that a cynical person might look at that and say they're just trying to attach themselves to this wagon train here of AI in order to sell some systems. Is that me being cynical, or is that actually the case?
I think that actually is the case. I think that an awful lot of the storage systems that are out there are taking advantage of the technologies that are available to become faster, higher throughput, simply because the technology exists. And if you find some whizzy technology and say this is fast and great, you have a marketing scheme for it and can sell it. There's storage systems out there that are incredibly fast, VAST comes to mind. There's companies like Pure and Fungible that have come up with NVMe setup configurations. These are things that are very fast, very high throughput storage that are begging for some need for them. And it's like, oh, hey, here's AI. That might be something that could actually make use of this WYSI storage we've put together.
So that's interesting. I wonder, so I put my data architect hat on, and it's so awful to work or live with a data architect because we're so dependent on common definitions of meanings. So when I think of storage, I'm thinking of the complete system, not just the hardware technology, but how that is put together, how it's configured, how it's optimized, how all the settings of it. So could we agree maybe a little bit that optimizing storage hardware in the storage systems and pipelines that feed into our networks can be optimized for these specific workloads?
We can agree on that if we actually know what the workload is. And I'm not quite sure I know what a generic AI workload is, because I'm not sure there is such a thing as a generic AI workload.
But I mean, meant compared to like a database workload or just blob, bunch of CSV files that just need to be maintained.
Yes, I can agree with that. And I mean, I guess one of the questions I have is an AI workload just the new name for a high performance computing workload?
I'm going to jump in on that one because I think that that's actually a good point, Andy. If you look at, and I don't know if that's the case, but if you look at the solutions we're talking about here, these solutions were designed for HPC. The engineers come from that background. The way that they're constructed certainly fits with HPC. It really looks like that's the case, that it was basically HPC storage that's now being repurposed as much as anything.
Well, and I mean, that sort of makes sense because the HPC market is incredibly small and incredibly slow to change compared to enterprise markets in general. And if you have this wheezy new storage, then certainly let's go find someplace to do it. But I guess, again, I don't know what a generic AI workload is, because there's all sorts of different AI workloads. You can consider the autonomous driving a version of AI, and that, while that certainly is compute intensive, I'm not sure that it's necessarily storage intensive. I think maybe the workloads that we're talking about would be more the deep learning workloads, where you actually need huge amounts of data and the ability to go look through it very rapidly. And I mean, this ties into another topic that we probably will discuss some other place on whether we want to use like object store for this versus a more traditional data layout.
Yeah, and I agree. Like I know that we lay people, because I'm not an expert in AI, talk about AI and ML and deep learning together as if they're all one thing. And there's lots of controversies about who's a subset of whom. But I am talking mainly about the types of machine learning workloads that I'm most familiar with: analyzing voice, analyzing video, analyzing photos, definitely bigger files than just a couple of spreadsheets worth of actually bits and bytes, usually.
Yeah, it really does matter what the application is. I mean, if you look at, for example, what OpenAI has done with some of their open AI models, you look at GPT-3, which is text, versus the new darling DALL-E, which is, all sorts of multimedia. These are very different workloads, very different sets, different data sets, and different requirements. I mean, storing millions of samples of text is a very different thing entirely than storing millions of pieces of music or millions of images. And analyzing those things is very different as well. And I think that's one of the things that people like Andy and I, with a background in storage, understand, is that file size matters, metadata access matters, the access pattern to that data matters. And I think that it's very likely that different AI applications are going to need different storage systems and maybe even different storage protocols based on the nature of the data that's being used, not just the plain size of the workload, the number of parameters.
Mm-hmm.
Right. What I'd like to see is that AI starts defining how they actually want to use their storage, consume their storage, rather than storage companies coming along and saying, here is the proper storage for AI. I think actually coming up with the requirements of what's needed of storage for AI would be something that I haven't seen, something that I would consider more useful than storage solutions coming along and saying, here we are for you, AI. AI driving the requirements rather than storage attempting to define what the requirements are for AI.
I think there's definitely an opportunity for overly motivated salespeople to tell potential clients, you have to do this or your project will fail, especially to organizations that are new or doing a proof of concept or anything. But I'd say that's true for all introductions of newish technology, that the surrounding infrastructure, people start questioning, can I use my same infrastructure? Can I manage it the same way? Does it have the same maintenance needs? Does it, the normal requirements, as you say, Andy, of going into what are your actual storage requirements?
Right. And I see companies out there that are simply saying, how can we create a high margin product that would be useful in this application?
Of course, you can't blame them for that. I mean, these folks are trying to sell their system. Also, you kind of can't blame them for using what they, the architecture they've already got, because that's pretty typical too. I mean, you got to sell what's on the truck. But, setting that aside and not being cynical about marketing, the fact that most of these specialized AI storage systems, the fact that most of them look fairly similar, I think says that maybe there is an intrinsic technical quality that systems need in order to support AI workloads. In other words, they need to be they need to have a lot of performance, a lot of capacity, and that means that they're probably distributed in terms of not a monolithic system. They're going to be a many node kind of system. They also need to be able to scale up performance and parallel access tremendously. They have to support a lot of clients, which sort of dictates what kind of protocols that they can use. I think that there are some intrinsic elements that are needed to support these applications.
I'd agree with that. I mean, and again, that's true for a lot of new things. I think that the main thing is it's, I keep thinking now back to Andy's point, is there's probably not one solution for all AI and all ML. And it's really going to depend on not only what are the source files, like what's the nature of the source files that's on that storage, but what is output? Like some machine learning jobs just do all that crunching and come out with a number, like a rating or a confidence value or a handful of numbers. And some of them come up with brand new videos and brand new music or something like that. So, you are correct that there's no one generic workload, but I bet you most people are thinking of optimizing for the storage of the input and the compute and the crunching that's happening, the algorithms, and maybe forgetting about what's being produced also should be optimized for that particular type of job.
I think what Stephen was describing is actually the direction that storage systems have been going for the past 10 years or so, though. It's kind of the same thing that VMware did with compute. The idea that storage is large enough and fast enough that you can have multiple tenants on it means that you need to come up with some way of actually providing those multiple tenants proper access to it. And this comes back to the old SolidFire days of we have very fast storage now, we have very dense storage now. How do we allow a bunch of different consumers to use it all at the same time? That is the approach that an awful lot of the newer storage systems are taking as well, where it's a distributed, as Stephen said, a distributed multi-tenant type system where lots of different users can use it in lots of different ways, and ones that need the high throughput can get it, and ones that just need access to vast amounts of data can use it that way. And yes, that might be something that AI could make use of, but it's also an enterprise use of storage as well.
And of course, we have to consider not just what do we mean by storage, but also what do we mean by AI. And I think that that's a whole other can of worms, because of course, what we've been talking about, I think, are systems that are mainly used for training purposes, not for inferencing or edge AI use cases. And for that, I think if we can open up that other can, that's going to be a very different storage solution, right?
Again, it's what you mean by AI, because there's a handful of different things, handful of different steps of AI. There's the ability to recognize things is one of those things that's fairly well established. The ability to figure out relationships between things actually is a very different step in AI that needs to be handled in a very different way. Like the next step beyond that is once you figure out relationships between things, if you can actually come up with what actions you take based on those relationships, that again is the next step farther down the AI chain. And I can't say for certain what either compute, memory, or storage resources you would need for any of the second or third or fourth level steps there, as opposed to just the first level inference and relationship that is what commonly is used for AI these days. It's like, oh yes, I can pick Stephen's face out of a crowd. Very nice. Now what do you do with that information?
But that being said, I think that a lot of these edge use cases are actually not going to require much storage at all. I mean, if you look at the kind of storage that's included in a self-driving car, for example, or a smart doorbell. I mean, we've got a smart doorbell over here. It doesn't really have any storage at all. It's got an SD card that it can store some images on and stuff, but none of that requires anything. So I'd say that inferencing is an entirely different subject, and doesn't necessarily require much.
So that would be the other portion of this is how much of AI's storage is actually cloud-based storage versus directly attached storage.
Well, I'd say with small applications like the doorbell I mentioned, or what we've seen from BrainChip, for example, at AI Field Day, I think that absolutely it can do those sort of tasks without much storage. But you're right that a lot of systems do use some cloud connected components, and that's one of those things you start looking at when you're looking at a lot of these AI systems. I mean, autonomous driving for the most part doesn't use cloud except as a batch location for telemetry data. I mean, most of that stuff has to be done in car, because otherwise, if you lose connectivity, you're going to run into a tree or something. Yeah, that doesn't work.
Yeah, and I think part of the other situation we deal with this sort of edge, not edge cases, but edge compute, is that are things like how durable is the storage, like the normal storage questions we would have. Like, I'm assuming that there are special needs for rugged systems, and that we can't have uh, certain types of drives that are really sensitive to heat, or something like that. And that doesn't change because it's AI or ML. I just think it changes how we think about storage and computing at the edge.
If you're looking at purely edge devices, it's also a matter of, are the edge devices working like a car that would be doing something autonomously, or are the edge devices actually attempting to gather data that's going to be meaningful in the aggregate later on? So again, it's a matter of how much do they need for immediate storage versus how much do they need for data gathering if it's going to actually be used later on. And again, those are two very different aspects of AI that would have two very different storage considerations.
And we have this other thing that we like sometimes at field days to talk about, is that a lot of things that are classified as AI devices just means they have a few logic statements in code somewhere, and it's not even what most of us would consider AI or machine learning too. So we also have to worry about that for storage optimized for AI. It might just be storage. Someone selling a complete turnkey system might just have storage, but say it's optimized for AI because it's optimized for regular data uses.
Yeah.
Right. And I actually remember that from the tech field day a few weeks ago,
Mm-hmm.
I guess a couple of months ago at this point, where there was some discussion about, is your solution AI, or is it just a matter of doing some logic on something and trying to figure something out?
Exactly. Exactly. I'd hate for those people to have invested in a specialized AI system just because some solution, filters data.
And that's actually one of those things. I think that AI is such an imprecise term. I guess like storage or data, it's such an imprecise term. If I say, um, storage is whatever, it's the same. It's the same deal, because it's like, wait, what do you mean by storage? What do you mean by AI? I get very frustrated. Yeah, there,
Storage.
anything can be storage. I mean, my father-in-law made cardboard boxes for a living. I guess that's storage, right? Um, and frankly, I mean, you look at a lot of the systems from the 1970s and 80s. There's a lot of expert systems
Yep.
work out there before machine learning really existed,
Mhm.
and that was AI too. It just was a completely different thing. So we do have to be very careful. And even within the realm, like I was saying, I mean, DALL-E uses GPT-3, but it has a very different performance characteristic, I would bet. Now, they're not talking about exactly what it is, but I'm going to go out on a limb and say that it uses very different storage, and it uses it in a very different way than even something that's based on the same core data set, because it is multimedia instead of just text. And I think that increasingly we're going to see this in a more nuanced way, which kind of leads me to the conclusion here, which is that the thing that may matter is not the nature of the storage architecture, but the way in which it's integrated with the overall AI solution. In other words, we need to have storage that is using common protocols and APIs that are truly integrated with various AI platforms, that so that the storage can be appropriately used by whatever application. And furthermore, we need to have ways of specifying the nature of the workload so that you can match the right kind of storage. I mean, this is the same stuff, Karen, right, that you've been dealing with your
Mhm.
entire career, I bet. When somebody comes to you and says, I have a database, you're like, cool,
Yeah,
let's talk about this.
exactly. And by the way, it's Microsoft Access and it's on a spinning rest drive on an 8-year-old laptop.
So let's wrap up then by considering our core premise. The premise here was that you need special storage systems to support AI. Andy, yes or no? Is that premise correct?
I would say that premise is not correct because we haven't even clearly defined what an AI workload would need for storage, or what an AI workload is. So trying to define what the storage is for that AI workload would be difficult. I think there are solutions out there that are fast and high capacity and all the things that you would necessarily need for potentially a big AI workload or an enterprise workload or whatever workload you want. And yes, they probably wouldn't be sold as a workload, as AI storage, but I don't really think that we have a definition of what an AI storage workload is.
And I'd say that I'm going to use the universal answer, not 42, but the fact that it's a big it depends. So I'm keeping my mind open that there may be certain types of storage systems that can be optimized for certain types of workloads, not for all of AI or all of ML or deep learning. I totally agree with that. And that people shouldn't just go out and adopt an AI solution because they have a smidge of AI in their own solutions, but should definitely do the cost, benefit, and risk to see if they can take advantage of optimized storage.
And I would say that I agree absolutely that it depends. I mean, we're consultants here. We can say that for any question. It clearly does depend.
Yeah.
But I'm going to come back to my contention at the beginning. And the nice thing about being the moderator is I get the final word. I'm going to say that the fact that big companies are partnering with big storage systems to have an integrated solution that goes with their big AI training pods, that to me says that the answer has to be yes, that you need special storage to handle special AI workloads. And I think that the argument that it depends is also yes, but it's yes only because not everything is like that. And not everything is going to use an NVIDIA SuperPod, for example. I mean, some things are going to be very, very different. So does it depend? Yes, but do you need special storage for AI workloads? In many cases, yes as well. So before we go, where can we connect with you all and continue this conversation? Let's start with Andy.
You can connect with me on Twitter at Andy Banta, and you can also see me tomorrow on AI Field Day 3, where I will be one of the delegates with both Stephen and Karen there as well.
You can find me on most social media at DataCheck, and I'm going to leave with some questions. Will Karen be able to convince Andy that it depends is the universal answer? And will Karen ask the vendors presenting at AI Field Day starting tomorrow all of these questions and more? So tune in tomorrow to find out.
I think the answer to those is yes. And as for me, you can find me on most social media sites at Foskett, and I will also be taking part in AI Field Day starting tomorrow. Just go to techfieldday.com to learn more. And if you happen to be listening to this a different day, then the videos are going to be posted to youtube.com/techfieldday, and you can see the conversations and the result of this whole discussion. So thank you for joining us for the On-Premise IT Roundtable. If you enjoyed this discussion, you can find it in your most favorite podcast applications, and please do give us a rating and give us a subscription. Also, you can find it on YouTube. Just go to youtube.com/GestaltIT-video. This podcast is brought to you by Gestalt IT, your home for IT coverage from across the enterprise. For show notes and more episodes, go to gestaltit.com/podcast. Thanks for joining us, and we'll see you next time.